Okay, here's Lab 7. Lab 7 is we'll say, virtual worksheet, and you could do this together as a group. You do have to submit one individually. It's only, the program wouldn't let me do it as a group, but you can work as a group to get your answers. Since it's just like an online worksheet, you don't need to do a video. You just come down here, you scroll down, and then you go to Worksheet 7. See, I give you an hour and a half to do it. Shouldn't take an hour and a half. There's about 10 questions, and they're going to ask you, different things about entropy, enthalpy, and delta G, Gibbs free energy. So just remember, enthalpy is a measurement of heat. Basically, it's how much energy it takes to make and break bonds. Okay, so it takes heat energy to make and break bonds. So how much? Entropy is it's a measure of chaos, if you want. I don't really like the word chaos. It's more of a disorder, if you want. Things, compounds and molecules don't like to be contained. They don't like to be, stuck in one place. They like to be free roaming. And so it's the energy involved with being free and being able to move around. So if you think about that, like if we look at solid, liquids, and gases, which one is the most free roaming? And that would be a gas. So it has the most amount of entropy because it can move around and it's free. Versus a solid has the least amount because it stays in one spot and it doesn't really move. So it has the least amount of entropy. And so entropy is a positive thing. You want them to, be free and moving because that's how they want to be. And so entropy is just, a measure of that. Delta G, Gibbs free energy, is sort of like the full total amount of energy in a compound. So when you look at enthalpy, the heat energy, when you look at entropy and you look at the temperature, what is the total amount of energy? So it kind of combines all of the energies and it gives you a total. How much energy is associated with this molecular compound. And if you want to look at it for a reaction, if you have a negative Gibbs free energy, total energy, that's when you're considered spontaneous because you're releasing energy, okay? Because you had so much energy that you had some left over and it's released, and that's positive because we want to gain energy. So a negative Gibbs free energy means it's spontaneous, meaning the reaction will go on its own. It doesn't need any help. Versus if you have a positive, that means you need more energy. It does not have enough energy to go, so you need to put more energy into a reaction. And that needs like heat or something like that to create a go, or a catalyst. So we're going to be looking at that. There's some problems associated with enthalpy and work and energy. So all of these basically tells you, the likelihood of a reaction to go, which is important, to calculate, because you do need to go. Is this reaction going to be spontaneous, non-spontaneous, and it's good to calculate if you can before everything occurs. There's also a chart in most textbooks that give you the energy associated with individual molecules. So you could do, the products minus the reactants and calculate that. It'll give you a good idea, will this reaction go on its own, or do I need to put a little bit more heat or something into it? So that's why you do it. It just, helps you decide how to do the reaction, basically, if you need to put energy into it or not.